If we now look at the ADF needle, we can see that it's pointing to a bearing of 195. This basically means that if we treat the aircraft's nose as 0 and go around in a clockwise direction 195 degrees, that's where the NDB is. Seeing as the tail in that case would be at 180 degrees, assuming that the aircraft isn't too bent out of shape, that puts the NDB behind us and to the left. If your tail is not at 180 degrees to the nose, you've got bigger problems than needing to find the NDB anyway. So the shortest turn to start flying to the NDB would be a turn to the left in this case, which is what we're going to do. As the aircraft turns, you can see the needle show a constant change of relative bearing because as we're turning, the angle between the nose of the aircraft and the NDB is constantly changing. So let's talk a little bit about homing. The idea behind the technique of homing is to keep the relative bearing of the NDB from the aircraft always at 0. This means that the aircraft is always pointing nose first directly at the NDB. The way that this will be displayed on the instrument is the ADF needle should always be pointing directly upwards towards the nose of the aircraft, which is the N or 0 degrees relative bearing indication on the display. If the needle deviates from this position, then a turn must be made to return the needle back to the N on the display. Here for example you can see that I've rolled out a bit too early and the needle is showing a relative bearing of around 350.